All right, starting off with section 1.1. So what's going to happen now is I'm going to do entire sections in books, and I'm going to start off here with Precalculus 5th edition, Mathematics for Calculus. I believe this is the one that's used with, I want to say, I can't even think of it now. It's one of the most popular online content management system for mathematics for high schools. So anyway, WebAssign. That's it. All right. So what I'll go ahead and do is I'll do the first section here, and we know why I might as well. All right. So starting off, 1 through 81. So question 1. We're going to list the natural numbers, integers, rational numbers, and irrational. I'll do these problems quickly, and then you can just look. And the other thing, too, to remind you, is the work that I do will be downloadable as a PDF, and I'll have other items in the description. And I'll get better at this as I go. This is my first go, so instead of short problems, we'll be doing long problems. Okay, so starting off, natural numbers. Question 1. So natural numbers are only numbers used for counting, and it doesn't include 0, but includes 1 all the way up into infinity, and they're integers. And the only one in this instance for question 1 for A, natural numbers, is going to be 50. Because negative 10 can't, because it's less than 1, and 0 can't be. And the rest are decimals or radicals or repeating numbers. Okay, B, integers. Well, we'll do it in order. So negative 10, 0, and that's it. 0. Oh, and 50. Sorry. C, rational numbers. So let's take a look here. I should just put them at the 0. Sorry. 0, negative 10, 50. A rational number is not going to, it has it can have repeating decimals, but it can't have an indefinite number of numbers that have no pattern at all. So 50, 22 over 7. That's actually that's a value that's used on calculators that don't have pi. 0.538, 1.23 with the 3 repeating, negative 1/3, and that's it. And now we want the irrational numbers. And the nice thing about this is irrational numbers, well, it's pretty much going to be what's left over. So it's going to be the square root of 7 and the cubical root of 2. Another way to say the cube root of 2 is actually 2 raised to the 1/3, but just so you know. Okay, so that's question 1, 80 to go. I'll speed up here. So question 2, A. So we want natural numbers. It looks like just 11 here, because we can only pick 1 through infinity, where it's only integers. Would 16 be a value? I do not know. Let me look really quick. Yeah, actually it would be. 16's kind of, it's not really a trick question, I would say, but the square root of 16 works because the square root of 16 is a perfect square. It's 4. Write that. If I don't show this in the notes, it's going to be confusing. So there you go. That's equal to 4. Okay. So answer B. Integers. So it's going to be equal to, we'll include negative 11 this time. We'll have 11 square root of 16, which is 4. And that's it. For C, rational numbers, we'll have 1.001, 0.333, negative 11, 11, 13 over 15, square root of 16, 3.14. It's a truncated version of pi, and we'll have 15 over 3, which is the same thing as 5. And actually, I'm sorry, 15 over 3. It's equal to 5. I don't know why I didn't include that. I don't know. Yeah, sorry. This should be 15 over 3. 15 over 3. And 15 over 3. And then finally, D for irrational numbers. It's going to be negative pi. And that's it. Okay. All right, so moving on. So we're going to do properties here really fast. So what about the first one? This is going to be the commutative property, because it doesn't matter which way. So commutative property. Sorry. This is going to be the distributive property. It's associative because it doesn't matter how you add these. Even though the parentheses are, you will perform whatever inside the parentheses first, but it doesn't matter how we do that. Okay, so next one. This is distributive property again, I believe. Property of real numbers. Distributive property. Property of addition. This is distributive property. Because you multiply the 3 across. Factor. I have to look at my notes here. Distributive. Okay. Commutative, so we'll have 3 plus x. For associative, we can just do this like this, where we do 7 times 3 times x. For distributive, we'll have 4a plus 4b. We distribute the 4. And then finally for question 14, all we're going to do is we factor out the 5, kind of reverse distribution, 5, and we have x plus y inside. That's it. Okay. So we're going to use the properties to write the expressions without parentheses. So starting off with 15, distribute the 3, so we end up with 3x plus 3y. 16, we end up with 8a minus 8b. 17, we end up with 8m. And then here we can multiply by 4 and negative 6. We get negative 24. Divided by 3 is negative 8. So we get negative 8y for here. So the 2's cancel out. So we end up with negative 5x, negative, negative, positive, plus 2 on the bottom makes this a 2, so it goes plus 10y. Here, distribute 3a, so we get 3ab plus 3ac minus 6ad. That's an A. Okay. All right. Next problem set. 21 through 26. Yikes. Okay, so perform the indicated operations. What we need to do here, we need a common denominator. It looks like our common denominator in this case is going to be 30. So we're going to have, I can still do this. All right, so this ends up being 9 over 30 because we can multiply top and bottom by 3. And this is 8 over 30, so we get 17 over 30. And I'm going to work the column. Well, yeah, I'm going to go ahead and work the columns. All right, so common denominator here is 15, so we have 10 over 15 minus 6 over 15, because we multiply by, that's going to be 9. So it ends up being 1 over 15. So distribute the 2/3 here. So we end up with 2. 2/3 of that's going to be 4. 4 minus 1 gives us 3. All right, so FOIL here. First, outside, inside, last. So we're going to get 3 minus 12/5. Yikes. Plus 1/4. I don't think I'm going to be able to read this. Minus 4 over 20. Yikes. And what does it give us? So 20. All right, so we'll do 60 over 20 minus 48 over 20 plus 5 over 20 minus 4 over 20. So this becomes 1. And then this becomes 12. We add those, so we end up with 13 over 20. Okay. So this is 13 over 20. All right, so over here, common denominator 2, so multiply the left by 3. So we end up with 6 over 2 minus 2/3 over 3, or over 2. So we end up with 2/3. So that ends up being 6. 6 minus 2/3 is going to be 5 1/3. 5 1/3, 16 over 3 divided by 2, 32 over 3. Am I right? 32 over 3. I was wrong. It's 8/3, so 8/3. 6 over 2, which is the same thing as 3, minus 1/3. Yeah, that makes sense. 9 minus 1/3 is the same thing as 8 over 3. So 9 over 3 minus 1/3 is 8/3. Okay, that makes sense. Yikes. All right, so over here 2, so we end up with 5/4 over 1/2 minus 1/3 is equal to 1/6. Because 3/2 minus 2, 3/6 minus 2/6 is 1/6. So this ends up being equal to 30 over 4, which simplifies down to 15 over 2. Pretty sure anyway. Am I right? I am. Cool. All right. So starting on the right side here, 1/4 plus 1/5. So this is going to be equal to, common denominator is 5/20 plus 4/20. We end up with 9/20. So 1 plus 5/8 minus 1/6. What we're going to end up with here with is, what's common denominator? 24. So 24/24 plus 15/24 minus 4/24. (39 minus 4) is equal to 35/24. Common denominator is 18. So we get 16/18 plus 9/18, which is equal to 25/18. And we multiply by 1/4. So essentially, we end up with 72. So 25/72. We could FOIL these, or we can simplify them first and then multiply them together. So we can do that. So we end up with 1/6 times 5/6 gives us 5/36. Multiply the numerators and then multiply the denominators. Okay. So we'll do this first. So 12. So 1/8 minus 1/9. Same thing as 9/72 minus 8/72. We get 1/12, and the same thing as dividing by fractions, the same thing as multiplying by the reciprocal. So we get 72/1. I guess 12 goes into the 7 times, so we end up with 7. And finally, for answer or solution 26, what's going to happen here is add the top and bottom separately. So we end up with 2/5 plus 1/2. So it's going to be 4/10 plus 5/10 divided by this should be 30. This is 30 here. Okay. So it's the same thing as 9/10 times 30/9. This becomes 3. This is equal to 3. Okay. So moving on. Oops. All right. So 27 through 28. All right. So this is just greater than, less than, greater than, or equal to. So this is how you read these. This is greater than. Excuse me. That's not right. If you were to read these out loud, so this is less than, greater, because you reference the first number. And this is equal. Okay. So this is 3.5. So that means 3 is less than 3.5. -3, -3.5. So just to be careful here, this is a little counterintuitive, but on a number line, let me just draw a number line. This isn't perfect, but it's to serve its purpose of just showing you what it is. So -1, -2, -3, -4. So any number on a number line, any number to the left of it's less than. Any number to the right is greater than. So here, -3, which is about right here, and then -3.5. -3.5, or so -3 is greater than -3.5. 3.5 and 7/2 are the same thing. They're equal to each other. 2/3, you got to be careful here. It's repeating sixes all the way down. So 2/3 is less than 0.67. That's usually 2/3 rounded to 2 decimal places. Greater than, because it's positive. And these are equal, because once the absolute value sign is applied, they're the same value. Moving on. So 29 through 32. Is inequality true or false? This is false. And the reason why is because -6 is greater than -10. It's to the right on the number line. Square root of 2 is equal to like 1.718, so true. True. Because the higher value you get up, so if you had 1,000 over 1,001, it gets closer and closer to 1. False. Because -1/2 to the right of on the number line of -1. So -pi is greater than -3. False, because pi is like 3.1459 and it goes on, so it's false. Maybe I should capitalize false. All right, so true. Even though it's greater than or equal or less than or equal to, that's still valid as long as it's less than. If it was 9, it would be. If it was 9 is less than or equal to 9, it would be true too. False, because this goes on forever. True. Okay. Sweet. Let's keep moving. And like anything else, I mean, it's nice if you watch this video, but if it's not good, you can just download the worksheet and find the answers you need. All right, so write each statement in terms of inequality. X is positive. All that means, I had to look real quick, so it just positive, anything greater than 0 is going to have a positive value. T is less than 4. A is greater than or equal to pi. X is less than 1/3 and greater than -5. There we go. The distance from P to 3 is at most 5. This is you had to be a little careful here because it's an absolute magnitude. It's going to be absolute value of P minus 3 is at most, so less than or equal to 5. So it can't be more, but it can be 5. So less than or equal to. Z is negative, or Y is negative. Y is less than 0. All right. So moving on. So, oh, you know what? I got to include those. I got them. All right, I got these. There we go. Z is greater than 1. B is at most 8. So it can be 8, but it's that or less than. W is a positive and is less than or equal to 17. Yeah, that's right. So it's got to be positive, greater than 0, but it's less than or equal to 17. Y is at least 2 units from pi. Because if the reason for this is because when you subtract, so let's say y is 2, you subtract 2 from pi, or you subtract, not just if it's not 2, but whatever y is, you subtract from pi, you'll get that result. But if less than or equal to pi, so it makes up for that no matter what, below pi or above pi. All right. sometimes those can be kind of funky to explain. All right, 35 through 38. Oh boy. Alrighty. All right, so for here, what we want to do is when we have unison, or excuse me, this is like a Venn diagram. So this means everything included in both A and B. So in this instance, it would be A and B, so be 1, 2, 3, 4, 5, 6, 7, 8. What this means here, the upside down U, is it only includes what they both have. So in this instance, 2, 4, 6. And usually you write these with brackets. So B and C, we will have 2, 4, 7, 8, 9, 10. And what about B? What overlaps for B and C? So we'll have 2, not 2, sorry. It's going to be 2, 2, 2, 4, 6. You know what? I think it's none of them. Or am I wrong? Oh, it's 8. See, only 8 shares them. Okay. Okay. All right. 37, A and C. And the only overlapping value is 7. All right, let's move on to 38. So all of these, all right, well, I'm glad it's the last one because I can write them all out. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And it's an empty set. And the reason why, you look here, 7, 8, but it doesn't work when all of them were combined because neither one, all three of them all three of them do not share exactly one value. Okay, so let's move on to 39 through 40. Ew, same principle. Okay. I don't know how I'm going to write this. If I'll write, yeah, I figured I'd write like that. All right, so for 39, I'll write an interval notation. So B and C less than 4. And so that's going to be negative infinity, 2, 4, but we have 5 here, so everything included is going to be 5, and we're going to have a closed bracket. All right. Part B. So that means negative infinity up to positive 5. So what do they include together? So less than. So it's going to be negative 1 because it doesn't include it, up to 4, which it doesn't include. So it's going to be open-end brackets on both. Okay, 40. All right, so let's go ahead and start with 40. So A, include what do A and C have if you include everything together? So A, anything greater than -2. And when you include C, you're also going to get -1. So we'll have -1. It doesn't include -1, but everything up to -1 or down to -1. And then we go all the way up into infinity. Oops. Because A, anything greater than -2. Oh, you know what? I made a mistake. This should actually, A encompasses all of C. So this should be actually -2. Okay, sorry about that. All right, so what do they overlap with? It's going to be -2 to 5. Okay, sweet. -2 to 5. Oh, shoot. Sorry, this is B. I didn't include it. Did I get this one right? B, and C. Yeah, I did. Okay. Getting these mixed around. I'm sorry. This is my first long form video, so I get a little bit of a break, right? At least I hope so. All right, B and W. B and C. Okay. Okay. So we're just converting interval notation to inequality form and then graph the interval. Yikes. All right, so something like this. Moving along. So because it includes it, we fill in the dot. Doesn't get so bad once you get used to it. Oh, shoot. I jumped ahead of myself. And I'm just drawing this really quickly here. I mean, you can scale this however you want. All right, so then we have 2 included. Jumped ahead of myself again. And it goes all the way into infinity. Oops. And here, you can't have less than or equal to for for infinity values. All right, so then less than 1. So it goes off into oblivion. And then we just have 1. Okay. All right, more of these. It's kind of the reversal. So what we do in here, so this is negative infinity up into 1. Graph it, so it's just going to be, that includes 1. All right. And this is filled in here. All right, so greater than or equal to -5. Greater than 1. And then fill this in, make it thick. I need to figure out some kind of quick, maybe we can do this. Does that work? That does work. It's a little extreme, but it works. Okay. It's a good start. Okay. Express each set in interval notation. So if there's a solid line, it's going to be a brick like that. So it's going to be -3 to 5. Open, so it's going to be -3 with a parentheses instead of a bracket, to 5 with a bracket, 0 to 2, -2 to 0 with a bracket. Okay. All right, so we can start with the easier ones. Basically, when you have the standard U, unison with, everything that overlaps with them. So essentially, they're the right and the left of each overlap. So it's going to be the leftist one, -2 to 1. So it's going to be essentially -2 all the way to 1. All right. And this is going to be filled in. What's not included? Yikes. So it's going to be -infinity. Or not included, but what do they overlap? So it looks like only -1 to 0. All right, so 57. Zero to 6. But 6 is bracketed, so it's going to include it, so. It's going to bracket both. And 58. -4 to 8. I'm sorry, I just can't freaking get this right. All right, what about 59? So we want to cover everything they cover. It looks like it's going to go all the way to negative infinity, up to -4. We'll have 4, which then goes to infinity. Okay, so we'll move on. Simple enough. 173. 5 minus the square root of 5. And the reason why is because 5 is greater than the square root of 5. And since the square root of 5 is a rational number, you just leave it in the exact form, which includes a radical. 10 minus pi. Because 10 is greater than pi, when you subtract pi from it, you get a positive result, and which is the same as whatever you get after the absolute value sign. Okay. 63 through 66. Yikes. All right, so what we get here is 6 when we evaluate the absolute value signs, -4. We get 2 inside. Absolute value of 2 is 2. 2 minus 12. Absolute value sign of that, so that's -10. Absolute value of -10 is equal to 10. Oh, sorry. I'll just do the left column first. So we get -12 on the inside here. Absolute value is equal to 12. So absolute value of -1 over 6 is 1/6. All right, so then over here we get -1 over 1. It's -1. -1 minus the absolute value of 1 minus 1. Ugh. It's like the absolute value signs and the ones are the same thing. So this becomes 0, so we get -1 minus 0, which is equal to -1. All right. It's -1 inside. We get 1. All right. Moving on. I might actually get done with this thing. This goes up to problem 81. Okay, so find the distance between the two squares. So 2 units plus 3 units is equal to 5. This is negative 2.5 to 1.5, so it's 1.5 plus 2.5, which is 4. 15 is just subtracting. Absolute value sign, so it's equal to 24. Ugh. So basically, you just take the absolute value of that and add it. So it's going to be 11 over 8 plus 3 over 10. So 10, so that's 110 over 80 plus it's 8, so 24 over 80. 134 over 80. I don't know what that is. 40, 72, 70. And that's divisible by 2, 17, 67 over 40. All right. And 67 is a prime. Let me make sure that's right. Cool, it is. All right. Just need to make sure. All right. Keep going. So, next step. These are really nasty. All right. So, for A, common denominator 15. Now you just multiply them together, so we get common denominator 105. So we end up with 5, negative 5 minus 49 all over 105. We end up negative 18, so 18. So it ends up being 18 over 35. It's kind of messy. $38.57. You just add one to the other, so we end up with 19. And finally, with this, it's just 0.8. Okay. Plug it into your calculator, check it out. Finally for C. Which simplifies down to 19 over 33. Okay. 72. Oops. Sorry if I'm just running through this really fast. I'm not going to explain everything. But essentially you're working this, setting this up. Divide through by 100. So two decimal places. Oops. 990x is equal to 5,180. You subtracted these from each other, and then you just divide through by 990. And that's how you end up with 518 over 99. Okay. Part B. Three five 3 5. Moving on, 73. So we got a garden. She decides to make it longer, as shown here. Which property real numbers tells us that the new area can also be rewritten as a is equal to 600 plus 20x. I guess a distributive property, because you're just distributing when you multiply it's side times side, but you're multiplying by, you're distributing the 20 across the 30 plus x. So I'll write this out. Okay, cool. Ooh, I gotta include the bar graph. All right, so all we're doing is we're just subtracting t naught and then t sub g, t sub o, t sub g. I'll label these t sub g. Excuse me, that's not right. T sub naught, t sub g. So all this ends up being is equal to, so this is t sub naught minus tg. Okay. So I can write on these. So this is just, so that's just 0. This sucks. I don't even have a ruler on me. I'll guess this is 71. Sorry. All right. So basically, I'll just write this out and start it again. So just a tedious exercise. And if you have any negative values, it just becomes absolute, like the magnitude of difference. Okay, next problem. So a post office will only accept packages for which the length plus the girth, width, or distance around, excuse me, is no more than 108 inches. Thus, the package can be figured by the following equation. Will the post office accept a package that is 6 inches wide, 8 inches deep, and 5 feet long? Distance around. Okay. What about a package that measures 2 by 2 by 4? All right, so all you have to do here is you just plug and play. So for part A, this is just going to be 5 feet. So 5 feet converted 60 inches. So 60 inches plus 2 times 6 plus 8. 60 plus 2 times 48. 60 plus 96. Is it less than 108? No, it is not. What about a package that's 2 by 2 by 4? So this is still A. And it's still no. Oh, I was wrong. I don't know why I multiplies together. It should be 24. 28. What about the second part? No, because that's 96 plus 1 or plus 48, which is going to be 144, which is not less than 108. Okay. Okay, so part B, what is the greatest length for a package that has a square base of 9 by 9? So for that second part, what we're going to do here is we figure L plus 2 times 9 plus 9, and then we just subtract from 108. So we end up with, so that's 18 times 2, which is going to be equal to 36. So 72 inches greatest. Or 6 feet. 72 divided by 12 is 6. Okay, so next problem. 76. Find the sign of each expression. So A is greater than that, so this could be negative. B is less than, so this is positive. B times C They're both negative, so it's positive. A minus B. A minus B. I guess that could be positive or negative. Positive, I guess. Oh yeah, that's right. C minus A. Negative. A, B times C. Positive. Because these two numbers here become positive, they're both negative, and that makes a positive. Positive plus a positive is a positive number. All right, AB plus AC. So that's negative. Negative. So negative. Positive. Negative. Negative. So positive. Negative. Is H. B is negative, but it's squared, so it becomes positive. A is positive, so this is positive. All right. Product of two rational numbers are rational numbers. Is the product of two rational numbers necessarily irrational? What about the sum? The sum of two rational numbers typically is always going to be irrational, but the product can be positive. I'll give you an example. 7 times square root of 7 times square root of 7 is equal to square root of 49, which is equal to 7. But, like square root of 7 plus square root of 7, it's going to be 2 root 7, and that's still an irrational number. Let's see here. You could do like square root of 2 times the square root of 24. Not 24. 32. Some can't. Okay. Is 1/2 plus square root of 2 rational or irrational? Is 1/2 times square root of 2 rational or irrational? First part is irrational. One half times square root of 2 is irrational. Sums always irrational. Products sometimes, as in the previous problem. Okay. gets smaller, all right, so we want to locate square root of 5. All right, so locate square root of 2 on a number line. Can you locate square root of 5? Similar method, square root of 6. All right, so all we did is we know where 1 is, and we just go 1 up. We use Pythagoras theorem, and we get our radius of root 2. Then we just take a compass and drag it all the way down here, square root of 2. So square root of 5. Could we do that? Yeah, you can. For square root of 5, what you would do is you would go 2 over and 1 up. And the reason why you would do that is because you're right here, and then you just drag this down. It'd probably get you somewhere right here. Square root of 5 is like 2.23 or something like that. Yeah, something like that. Somewhere down here. Not exactly sure where, but okay. And same thing as square root of 6. You would just do 6 or 6, 3 square root of 2. It'd be a little bit harder. Two, 5, 4. And actually, for square root of 6, you would take square root of 5, and then you do 1. So you go like up here, and then you drag it down. That's it. All right. Yeah, this probably didn't show up very well for square root of 5. For square root of 6. A little bit confusing, but hopefully that helps you out. Okay, let's move on. Commutative, non-commutative operations. We see addition and multiplication are both commutative operations. Is subtraction commutative? No. Is division of non-zeros, real numbers commutative? No, and it's not allowed. All right, and that's it. Sweet. And it's a little rough, and some of these questions may not be answered so well, but it's a good start, and I'll get this figured out better, and I'll go flying through books, and hopefully this really helps you all out. All right.